Hello, this is Antonio Malorino. Most likely, most of you that are watching this have listened to me before. I decided to use this kind of weird title because my friends from Extension said that we should be innovative, about using some attractive title. And I've talked a lot about potassium, but I really think that there are three things that have to do with potassium and the interactions with other factors that really can reduce the profitability of crop production if we have a deficiency. Okay, potassium in Iowa originally was adequate or high in western regions, but was deficient elsewhere. Now, high crop yield in productive soils removes large amount of potassium. So even in western Iowa, some soils now have got into the optimum or maybe upper low levels, because of removal. On the other hand, continued fertilization and manure application over the years can build up soil potassium levels, and that has happened, in many places. But it's not as much as has happened with phosphorus, for example, when we have manure fields. There have been many decades of research on soil test method, calibration, fertilizer placement, and use of variable rate technology. So the key is that farmers or consultants need to know what are the optimal soil test values to be maintained and the application rates for deficient soils, and then need to consider removal. Because the maintenance is based on that, is the prevailing yield and removal. Okay, here I have some of so many pretty pictures about potassium deficiency that I have taken or people have sent me. On the left, we have corn, and usually corn, the deficiency is in the lower, in the older leaves, either early or late. We have some induced deficiencies. For example, the lower right, Mark Carlton, ex-field agronomist from southern Iowa, sent me that picture when it was dry. And then you have the effect of compaction there, inducing potassium deficiencies. On the right, we have a soybean. And you have heard me saying for the last 12, 15 years that most people have this idea that potassium deficiencies are visible only early. That's the top photo. But we have been confirming that many times upper leaves after R3, R4, those are potassium deficiencies too. There are other top leaves yellow syndromes there that could be diseases, but the potassium deficiencies are very typical. As you can see in the lower right photo, that's an experiment in the northern farm. And that deficient soybean plot there has got no potassium, and you can see that it matured actually earlier than each plot on the sides that had right potassium application. So you need to watch about deficiencies, but remember that when you see any of these deficient in the field, it's too late to do anything. Yes, if it is early, we can do some foliar applications, things like that. But so you need to be sure that you have the right soil testing, so you don't get these problems. So soil testing for potassium involves higher uncertainty than for P or pH. We have been working for so many years, not only here, but in Illinois, Minnesota, and there are several complex reactions between the soil potassium pools that are affected by rainfall and soil moisture. They are affected by recycling from crop residues. The potassium in the plants, even when the corn or beans start to mature, start losing potassium to the ground with rainfall. And But then if there is no rain, of course, that potassium stays in the plant or in the residue. So the interaction between the rainfall and recycling from plants or crop residues, I mean, it's important. And then we have the other thing, which is the soil sample drying in the lab. You may be aware that we introduced the moist or slurry sample handle procedure back in 2013. So the fall, right after harvest, is a very unstable time for soil K testing. Many things are going on there. But of course, few people want to sample in the spring. They just want to be ready to apply the fertilizer in the fall as soon as possible after harvest. Now, in addition to the soil test levels, we have all these issues that affect potassium much more than phosphorus or pH, which is the induced deficiency, even when we may have some high soil potassium. And that happens when we have a dry, wet, compacted, or loose soil, and then when we have root diseases or root pruning by insects. So all these things make really potassium management more complicated than phosphorus or lime. Now, the guidelines in the Iowa State University PM 1688 extension publication were updated last February. Just as a reminder, the ammonium acetate and the MELIC3 test give similar test results, doesn't matter. But the potassium tests of field moist or slurry samples introduced in 2013, in addition to the dry test, is more reliable in many soils. The updated interpretation categories for the potassium test of field moist or slurry and dry samples in the lab were that we increase slightly the upper borders of the very low and low classes, but we have a large increase of the upper boundary of the optimum class, for which maintenance based on prevailing removal is recommended. We decided to do this because we believe that it was too narrow before. We have so much variability out there, so much lab bias, that so we decided to increase it just to be sure that we are not recommending something that will result in deficiencies. So this is just, I put together a couple of, actually 3 tables of the new PM 1688. We have in the top the dry samples for potassium. As I said, it's either the MELIC3 or the ammonium acetate, it doesn't matter. But the ppms are different for the dry test or the moist test. They're very different. That's why we have to do all these field calibrations with yield response. And then there in the bottom of the table, we have the rates. We increase a bit some of the rates. Now remember that for the optimum, those rates are defaults for those yields that are there, 210 and 70 bushels per acre, because labs have told us, that many farmers don't give them the yield level when they want to maintain. But this is just a default. People should use their own prevailing yields for the field or field sections. Now, I have been showing this chart a lot since last December, actually. What it shows is the classic relationship between relative crop yield response and either the dry ammonium acetate test on the left or MELIC3 is the same, and on the right, the moist test. Okay, and the black dots is corn, the open dots is soybean, and put both together because there is not really difference between the two. So at the top of the graphs in red are the old categories that were in place since 2013 until last December. And then in the bottom in blue, and the blue lines up, indicates the new categories, the one that we have since March. So you can see, of course, the relative yield increases as the soil test increase because it's relative yield in relation to the control that receives no potassium. Okay, and as you can see there very clearly, the optimum category now is much wider and goes up more. Uh, that's the most significant change. That was due because of the data show there is a need to do it, but also because of the things I said, the high variability, the lab bias, and so forth that is going out there. And the bars graphs inside show the probability of response of at least a 95% response. And this is what we want to see. In Iowa and Iowa State, we have had since the early 90s this criterion that we defined these categories based on probability of response, something like they are showing there. So that's where we want them to be. That's why we call it the very low class, that name, and the low and the optimum, and then the high and the very high. There is very low probability of response. Here, what I show is the same data set, but now across corn and soybean. But these different colors of the symbols are soils with different drainage. We've found that in when we did the update in 2013 that we introduced this test, that the main goodness of the moist test is that a ppm value by the moist test has the same meaning, about the same meaning, for all soils, all conditions, independent of the drainage. If you look at the dry test, do you see those red points that are below about 80%? All those with huge responses, okay, they are in the low class. They should not be there. They should be in the very low, okay? And those are soils that have moderately poor to very poor drainage. And I put there some of the soil series in Iowa that these things happen, okay? If you look in the right graph with the moist test, these soils are where they should be. So essentially, all the soils are aligned in that response, which is not as neat as for phosphorus, which I'm not showing that today, but obviously is much better. So people that use the dry test in some of those soils that are in red, they are getting hit. They are not applying enough potassium there because the dry test says that it's low when actually it's not. It's very low. You understand that? If we have high testing soil, there is not much of a difference, okay? But that's the problem. Okay, this chart also shows something that especially people from Northwest Iowa keep asking me, because some people out there, especially in South Dakota, they are talking that we need to use potassium saturation instead of the soil test for potassium, or in addition to. And we do not have to. Do not use it. I mean, either for the dry or for the moist test. You see, those yellow points are supposedly in the range that some people say that the potassium saturation should be. And as you can see, those yellow points go all the way from the very low to the extremely high. You see, if somebody, uses or recommends the potassium saturation, the only reason would be that they want to sell more fertilizer. They want you to apply potassium in high testing soils where you should not. You can save lots of money. Okay, these are the economics. And I have seen this shown before. These are net returns. Okay, these are not yields, these are not bushels, and these are not returns to the crop. Okay, these are net returns from K per acre. That's what they are. In the top, we have the moist or slurry test, and we have three scenarios. On the left is the good prices. In the middle is something probably like we have now. And then on the right is really horrible prices that actually we never got so low. And then in the bottom three graphs, that's the dry test. I mean, you don't need to be a PhD to see that the three graphs in the top make more sense than those in the bottom. Essentially, using the dry test is good only to tell you when you have an extreme deficiency or you are high or very high. Otherwise, not useful. If you want to fine-tune potassium management, you cannot use the dry test. And then the black points there is corn, and the white is soybean. So the key issue there is that, especially for the two scenarios, the left one and the center, which are reasonable prices, I mean, you see that the probability of large benefits from fertilization in soil testing very low are there. That's why I tell people, even those that rent land, as long as they are sure that they have that field for one more year, they should not cut when the prices are bad. They should not cut fertilization in the very low testing soils. Actually, no matter the price, except if it is horrible, like in the rightmost graph, that we were not there, even in the worst bad prices of a year or two ago. So you need to look at your soil test. You need to interpret right. You need to do good sampling. You need to do a soil sampling that you can trust. Okay, that's why I favor grid sampling, a well-done grid sampling with several cores or a management zone sampling. So then you can trust some of these numbers in order to make a better profit. Now, this is the core of the talk today. Nitrogen by phosphorus and by potassium interaction. What's an interaction, okay, between two nutrients, for example? Say an interaction occurs when the proportional yield increase from applying one nutrient changes with the rate or soil test level of the other nutrient. So what you get in terms of what is the soil test that give you the optimum or higher, or what is the fertilizer rate that gives you, some yield level, that is not independent of the level of application of some other nutrients, okay? So in terms of interaction, this is one of the most clear that we have seen in Iowa. An Ohio study with corn I'm sorry, it says they're 1900s. No, it's 1995. Okay, there's a mistake there. Showed a clear interaction nitrogen by potassium. Okay, what was the interaction? That more nitrogen was needed when we had deficient soil test potassium. Then results of a long-term study in the Northern ISU research farm with continuous corn that was summarized in 2002. We have the three nutrients variants there with different rates: nitrogen, phosphorus, and potassium. I will show no interaction between nitrogen and phosphorus, zero. We saw a clear interaction, nitrogen by potassium. And the interaction was that a K deficiency reduced the corn capacity to use applied nitrogen. So this is shown in these two charts. The graph on the left is the work from Ohio. Now, what they have was different soil test levels, okay? So the dotted line was the response to nitrogen when they have low soil test potassium, and the full line is when they have optimum potassium. So you can see very clearly there that if you have low potassium, if you are applying those rates, the corn is not using them. So you need to have optimum soil test potassium in order for the corn to use the nitrogen. Then on the right is this that we found with Dave Ruber, the superintendent of the Northern Farm, and Jason Dodd, a graduate student. The details of this is published in some of the farm reports. And So what we have here is three different scenarios, cases, okay? So the top curve, solid one, it says optimum P and K. That's the maximum response that we got to the nitrogen applied, okay? Remember, this was continuous corn after many years, so the yields were kind of low. Then we have this dotted line that says low P, optimum K, okay? So you see that curve is parallel to the other one. That means there is no interaction. So that means that if you have a phosphorus deficiency, okay, of course you get reduced yield, but proportionally it's about the same for all the nitrogen rates. So we say there is no interaction phosphorus by nitrogen, okay? But then the other one, when we have the triangles, says low potassium, optimum phosphorus. Then it's a clear interaction. What happened? When we have low potassium, okay, you get the maximum yield with about 180 pounds of nitrogen, and that's all. But if you have the optimum potassium, you could get, much higher yield, and the rate of 250 pounds didn't even maximize the yield response. So I'm not saying that you should not care about phosphorus. You should care. But in the case of potassium, it's not just that the potassium limit yields because it's an essential nutrient and you need to apply it. It's that you will be applying the nitrogen anyway, but the corn with a deficiency of potassium will not use that nitrogen that you're applying as it should. Now, these are older research, so we decided to do some new research. So we did two sites, one at the northern farm and another one at the southeast research farm, that we have, these are averages of all those years that we put there. So in the northern farm, we essentially got what we have found before with potassium. We didn't have phosphorus in this case. We just have potassium and nitrogen. So you see the dotted line says no K. You see the maximum yield is attained with about 150 pounds of nitrogen, but it's a much lower yield that you get with potassium there. You see, if you apply more nitrogen, you get higher yield, and it is used by the corn. Okay, when you don't have a deficiency of potassium. On the right side, it's about the same. You see, slightly different curves. The maximum in this case is attained at about the same rate, about 225 pounds. But you will see that, of course, the yield is much better with when you have the potassium applied and not deficient. In addition to that, we have with John Sawyer until about a year or two ago, we have a demonstration here in what we call the field lab in central Iowa. And but this is not replicated, okay? This is not replicated. And these are averages of 3 years, 2015, 2016, 2017. And in the graph on the left, that's continuous corn, no till, okay? And we see almost exactly the same that we see. It's not replicated, but we get it exactly the same thing. When very low, with low potassium, the nitrogen, the corn is not utilizing that nitrogen the way it should. And then on the right, we have corn after soybean, no till, too. And we also have tillers, but I'm not showing that. So we see in all these experiments, two with many years replications, the old ones, and this one, it was a demonstration with no randomization or replication that you should not risk a potassium deficiency in corn. Now, the other thing is that I always get that question, is the potassium impacts on corn lodging or corn breakage. Okay, we don't have a nice study from Iowa because we never measured, or we were too busy with many trials, we couldn't do it or didn't see it. But this is a nice study from Tennessee that was published years ago. So they have 2 years, and then in the y-axis have the percent of corn plants lodged, okay? So in the first year, nothing. See, the soil test exchangeable K went from very low, 50, to up to very high, 450. Nothing happened, okay? All these points were just flat. But then in the second year, something happened, wind or I don't know what, but it's obvious there that what we consider low, okay, we have anywhere from 40 to 80% of corn lodging there. So, but again, you see, all the things means that you should not have a deficient salt test level, but does not mean that you should have a high or very high salt test level, okay? Some people are confused out there. They go to an extreme with this. They believe that they have to be high or very high because of these interactions. No. If you maintain that optimum that we recommend, you will get these things working okay. Okay, the other thing that we worked years ago with Matt Clover, he's in Cortiva now. We work with rootworm resistance. That was several years ago. And of course, the plants that are resistant to rootworm, they have better root systems. And you can see in the graph on the right that the red is when we have a corn that was susceptible to rootworm. We didn't put any insecticides, low yield, and the maximum yield was attained with about 109 pounds. When we have the resistant corn hybrid, we have much higher yield, and the maximum was attained with a lower rate of about 98 pounds. Again, another reason, it does not mean that you need to have high testing soils to reduce the impact of rootworm. It means that you have to have at least that optimum, at least with that maintenance rate that we recommend. You cannot afford to have a deficiency because then all the things start to pile up. Now, this is with soybean, and this also we worked with Matt Clover years ago. This was is an example of several strip trials that we work on farmers' fields. Okay, so on the left graph in blue, we calculated the averages of frog eye incidence. Okay, the light blue is the control that have no potassium applied, and the dark blue is with potassium applied. So you will see that as the level of potassium in the soil increases, okay, the level of incidence of frog eye decreases. And in the right is the same field. We have cercospora incidence, okay, and it go down up to the high or the very high. Now look at the yield responses there. The yield responses were small, and in fact, with a very high test, we have a yield decrease of about 5 bushels, okay? So it doesn't mean that you need to be very high, okay? But you should not afford to have a low testing soil. You have to have an optimum that you apply the right rate, and then you can reduce, if there is disease pressure, okay? Then you can reduce the indices, the incidence of these diseases. These were plot trials. This was in a northern research farm, okay? So in the graph of the left, we have soybean grain yield, okay? And we have 4 rates there. 0, 35, 70, 140. And then you see that there is a response mainly up to the 70 pounds, not much difference with the 140 pounds. But then when you look to the right, then you see how increasing the potassium rate decreases the incidence of cercospora, frog-eye spot, and brown spot. Okay, this is important. Seems that when there is a potassium deficiency, these bacteria or these fungi really like to get there, and then they do their work. They do reduce yield. But again, doesn't mean that you need to have an excess. It means that you should not have a deficiency. This is another side. This was in the Northeast Research Farm. Different responses. We have only 3 rates there. But there was a response up to 70 pounds. And then the plants with symptoms in percent on the right graph. Then we see that for several of the diseases, there is a significant decrease up to the 35 pounds, and in the case of brown spot, also up to 70 pounds. So this is another interaction. You see, we don't see this for phosphorus. That's why I'm not showing it. We don't see it. We see for potassium. Okay, as I said before, all this indicates that we need sufficient potassium, not an excess, okay? If we have a K deficiency, that limits yield of any crop because potassium is essential. It reduces the corn capacity to use applied nitrogen that you will apply anyway, most likely the same rate. May increase corn lodging or stalk breakage. It may, okay? Doesn't mean that will happen always. It may increase the severity or the incidence of some soybean diseases and also aphids. I didn't do research with aphids, but research in Wisconsin showed the same thing. The aphids really love the soybean that are low in potassium. Now, again, there is no evidence to support that higher than optimal soil test levels or rates higher than the recommended are needed. Okay? By applying the removal rate, according to prevailing yields to maintain that optimum soil test value over time, that's sufficient. Now, I have been saying this for a few years, and my friend Sawyer, now retired, he never liked that, but I said, John, that's what happened there. You see, in the case of potassium, it's better to err for a bit higher soil K maintenance or K application rates than err for less, because there is more uncertainty for K testing than for P testing because of the interactions for K that I show that they do not happen for phosphorus, and because potassium is not a water quality concern. I'm not saying that you should maintain high, very high. What I'm saying is there is uncertainty, and if you have a deficiency, you get hit multiple times. You get hit because you don't have enough potassium because it's essential, because the corn does not respond well to the nitrogen you apply, because you may increase corn lodging or rootworm incidence, or you may increase some of these soybean diseases that I showed you. So that's why we have these recommendations that we updated last March in potassium. That's why I was happy to increase that optimum higher level that it was. We believe that farmers cannot risk to have a potassium deficiency. They should not. So, how do we manage potassium wisely? Okay, use good grid soil samples, grid 2.5 to 5 acres, 10, 12 cores per sample. If you don't want to do that, then use management zones. Don't do grid sampling more than about 5 acres. It's not good. Use the moist or slurry potassium sampling handling procedure, especially in soils with moderate to very poor drainage. Like we have central, north central Iowa, and in other parts of Iowa. Maintain soil test potassium in the optimum category based on removal, but not yield goal, okay? You need to have an idea, a reasonable idea of what is the yield level and the removal on average, prevailing, okay? Use variable rate application in fields with large soil test or yield variation. This is important, okay? But as I said before, don't risk a potassium deficiency as long as you know you'll keep a field a year or two ahead. It's better to go wrong with a bit more potassium, but not less. And with that, thank you so much. I got into the 21st century, and some of my extension people advised me to put that thing there, that you can scan. That will take you to the soil fertility website. Thank you so much.